Dear student, in this topic we discuss about the factors on which the resistance of the conductor depends. For that, we should know about the difference between the resistor and the resistance. So, a resistor is an electrical component that limits or regulates the flow of electrical current in an electronic circuit, while the resistance is the measure of the opposite to current flow in an electrical circuit, and it is measured in ohms. Now to calculate the resistance of the wire, we should know the three things, that is its length, that means L, its area of cross section, that means A, and the resistivity of the material, that is ρ. Now let us discuss the first factor, that is the resistance depend on length, how it is depend on length. So the resistance occurs due to the collision of charge carriers and the atom of the wire. Then obviously there will be more collision in the longer wire, and when there will be more collision, that means the more obstacle to flow the current in the conductor. This obstacle is nothing but the resistance. So for the longer wire there will be more obstacle, that means its resistance is high. That means more collision means more resistance. So the total length of the wire will affect the amount of the resistance. And the longer the wire, the more resistance that there will be. That means R is directly proportional to L. That means resistance is directly proportional to the length of the conductor. Now the second factor, how it is depend on the area of cross section of the conductor. Now consider the two wires of same material but with different thickness or area of cross section. So whenever we circuit on, the electron will pass through it. And in the wider wire, what will happen? In the wider wires, that means the more thickness, that wire has more thickness, it has more area of cross section. So it allowed the more electron to passes through it than the thinner wire. Hence we concluded that the resistance of the wire decreases with increase in thickness. That means the relation of the resistance with area is R is inversely proportional to the area of cross section or thickness. Now after combining equation 1 and equation 2, we get the final equation R is equals to ρ into L divided by A. Here R is the resistance of the wire, ρ is the resistivity of the material, L is the length of the conductor, and A is the area of cross section of that conductor. So ρ is the constant of proportionality and it is called as specific resistivity. Every substance has their specific resistivity value. Its values depend on the nature of the conductor. For example, copper, iron, tin and silver each have different values of ρ, and depend on the value of ρ, its resistance is also depend. So in this equation it shows that the R, that means resistance, is directly proportional to the resistivity. So the substance which has maximum resistivity value, that means it has high resistance value. Now let's come to the conclusion. So initially we say that this R is directly proportional, that means resistance is directly proportional to the length of the conductor. So let's see how it is depend on the length. In the figure it is written as whenever we increase the length twice, its resistance is also becomes a twice. So in equation, in first case we see L dash is equals to twice L. Here L dash represent the change in length, that we consider here the twice of original length. Now put this value in our resistance formula. So we get the change in resistance value that is represented by R dash. So R dash will now become ρ into twice L divided by A. We get 2 constant here. So finally we get 2 into our original equation ρ into L divided by A. This ρ L divided by A is nothing but the original formula for the resistance. So we can put R in place of that. So we get the change in resistance is twice of the original resistance. That means we can say it as when we increase the length by twice, its resistance is also increased by value twice. Now what will happen when we increase the area by twice? That means our change in area A dash is equals to twice A. We put this value in our original equation and we get the change in resistance value. That means R dash is equals to half of original of resistance. That means we can say it at whenever we increase or whenever we increase the area of cross section or the thickness of the wire by twice, its resistance will become the half of the original resistance. And before we discuss that, the resistivity, substance resistance is directly proportional to the resistivity of the substance. That means the substance which has the more resistivity value, it has the more resistance value. Now let's come to our key point of the topic. First, resistance of a conductor depends on its length. That means a longer wire has more resistance than a shorter wire. Second, resistance of the conductor is depend on its area of cross section or thickness. That means the resistance of the wire decreases with increase in the thickness. Third, resistance of a conductor depend on nature of the conductor called as its resistivity. That means the substance which has very low resistivity like metal and alloy are the good conductor of electricity. So why it is a good conductor of electricity? Because the resistivity of that material is very low. That means its resistance is very low, and whenever the substance has low resistance value, it is a good to flow the current through it. So they are the good conductor of electricity. Thank you.